Hello everyone, it's me Amna and welcome to Amna's Learning Hub. I hope you all are fine and finding my videos helpful. I know I am uploading this video after so long, but from now onwards we are going to upload the videos on daily basis so that it will be helpful for you and you will be able to understand new things about chemistry. Okay, so if I talk about my today's video, it is about chemical bonding. Chemical bonding is the most important, you can say, the topic of chemistry, because the whole chemistry is depending on the bonds, how they are forming, how they are breaking, how the energy is involved, and what type of bonds do we have. So let's start studying this. First of all, if I talk about chemical bonding, so I must have an idea that when elements combine together, they form compounds, and the way through which they are combining together is called chemical bonding. For example, sodium Na is an element, chlorine Cl is an element. So when both of these elements combine together, they are forming NaCl, which is a salt, and this is a compound now. This was an element, this was an element. When both of the elements combine together, it is forming a compound. And there is an attractive force between these two elements. Attractive force between two elements is basically chemical bonding. I hope the chemical bonding and the concept of basic chemical bonding is clear to all of you. Now, we are diving in to study the types of chemical bonds, that how many types do we have and what are the processes through which these compounds are formed. For example, okay, so if I talk about chemical bonding, we have 4 types of chemical bond. First one is ionic bond. Second one is covalent bond. Third one is metallic bond. And fourth one is dative bond. Dative bond, also known as coordinate covalent bond. Right? So first of all, we are going to study about ionic bond. In chemistry, whenever something comes in front of you, first of all, try to break that word. You will eventually understand the definition or the basic concept or the basic idea of that process or that thing. For example, ionic bond, if I look into the word, this is composed of ion. Previously, we discussed about ions. We have 2 types of ions. First are positive and others are negative. So when elements having positive charges and having negative charges will combine together, it will be known as ionic bond, and the compound will be formed is known as ionic compound. So ionic bond is the bond between the cation and anion. When the bond is between cation and anion, this type of bond is called ionic bond. Next we have covalent bond. Covalent bond is basically by sharing of electron. When electron is shared between 2 elements, it is forming a covalent bond. Okay, ionic bond, for memorizing the ionic bond, the definition of ionic bond, you must have one thing in your mind, that is complete transfer of electron. Complete transfer of electron means one element is donating electron and other element is accepting electron, and when both of the elements, positive and negative, combine together, they form ionic bond. I will elaborate this point later in detail, like how the electrons are completely transferred, how the positive ions and how the negative ions are formed. In covalent bond, we have sharing of electron. Sharing of electron means, for example, I have two elements, carbon and carbon. Both of the elements have half-filled shells. For example, carbon has 6 atomic number, another carbon also has 6 atomic number. So that means the carbon will have, in center we have proton, and then we have shells. In first shell it has 2 electrons, and in second shell it has 1, 2, 3 and 4 electrons, right? So that means carbon is deficient of 4 electrons. We know that in chemistry every element want to acquire the electronic configuration of noble gases. What are noble gases? The gases which have complete outermost shells and which are non-reactive. So basically every element in every compound, every element basically wants to get the electronic configuration of noble gases and want to be stable by having 2 or 8 electrons in their outermost shell. So now carbon has 4 electrons, it is deficient of 4 electron. It does not want to lose electron, it does not want to gain electron. So basically electrons of carbon will be shared with other carbon. This one electron will be shared with other carbon. So both of the carbons will have 5 electrons, then they will share other, then they will share other. So by sharing electrons they are forming covalent compounds, or this type of bonding is called covalent bonding. Next we have metallic bonding. We all are familiar with the metals. So if I talk about metals, metals are very good conductors of heat and electricity. Why they are good conductors of heat and electricity? Because in metal, for example, this is the surface of metal. So metals have so many mobile electrons. What? Mobile electrons. Mobile electrons means freely moving electrons. So it has positive charge, and then we have so many electrons spreading in. So these electrons are conducting the electricity and the heat, and the bond between these positives and these electrons is called metallic bonding. Next we have dative bond or coordinate covalent bond. The word covalent is coming, that means there is some sharing. Coordinate means 2. Coordination, whenever coordination comes, it is between 2 things. So whenever coordinate covalent bond is formed, that means we must have a pair of electron, and pair of electron will be shared to any other element or compound. I hope this basic idea is clear to all of you. Now I am going to dive into the details of ionic bond, how they are forming, what are the properties, then covalent bonds, then metallic bonds, and then dative bonds. Before discussing the details of ionic, covalent and other type of bonds, I need to address 2 very important rules which are very important. I told you about the stability of elements, that every element want to be stable and want to achieve the electronic configuration of noble gas. So for stability we have 2 rules. One is duplet rule and second one is octet rule, right? Now duplet means do or die, do, du, or di, die means 2. So duplet rule means this is the nucleus, this is the first shell and it must have 2 electrons in outermost shell. When any element will have 2 electrons in outermost shell, it will be following duplet rule, right? So when any element will have 2 electrons in outermost shell, it is following duplet rule. And when an element, this is the nucleus, this is first shell, this is second shell, so 2 electrons in first shell, 1, 2, 3, 4, 5, 6, 7 and 8. So 8 electrons in second shell or the outermost shell, any shell which is outer, the outer one is known as outermost shell. So if the outermost shell have 8 electrons in outermost shell, so it is following octet rule, right? Octa, we all know that octahedral, octa, whenever the word octa comes, that means 8. So octet rule will have 8 electrons in outermost shell. Clear? So now I am going to tell you about ionic bonds and how the ions are formed. So for that, you must keep in your mind the duplet rule or the octet rule. Okay, ionic bond. Bond between ions. We have two types of ions. Cations, which have positive charge on them, and anions, which have negative charge on them. Now, how cations are formed and how anions are formed, and what are the groups in periodic table which provoke the formation of cation and which provoke the formation of anion. So for cations, metals, usually metals form cation. How? We know that in periodic table, the first column is the group 1 and it has alkali metals. Second one is alkaline earth metals, and then third. So any element which has 1 electron in outermost shell, which has 2 electrons in outermost shell, and which has 3 electrons in outermost shell, they are deficient of electron. If it has 1 electron in outermost shell, it is deficient of 7 electrons. So it will donate that 1 electron completely and will achieve the configuration of the nearest noble gas. For example, I talk about hydrogen. Let's say lithium. So lithium has 3 electrons in outermost shell. This is lithium. This is 3 atomic number and 7 is atomic mass. So this is the nucleus. In first shell, it has 2 electrons, and in second shell, it has 1 electron. So for getting stability and to following the duplet rule, it will donate this 1 electron and the remaining 2 electrons will be in the shell. So 2 electrons is following duplet rule and it is achieving the electronic configuration of helium. Helium is the nearest noble gas. Clear? So this is how elements donate electron, and when they donate electron, they get a positive charge on them. Why they are getting positive charge? Why not negative? So there is a chemistry behind this. We know that in a neutral element, the number of electrons and the number of protons are equal. In this case, it has 3 electrons and it has 3 protons, right? So when 1 electron will be donated, now it has 2 electrons and it has 3 protons. Proton has positive charge on it, so now it is having 1 more proton than the electrons, so it will be getting Li plus 1 charge, lithium positive 1, right? Same is the case with beryllium. Beryllium is the metal. It has atomic number 4. It is in group 2. Now, nucleus, first shell, 2 electrons, second shell, 2 electrons. Now, it can get the stability by 2 ways. First one is either it will donate 2 electrons and will follow the duplet rule, or it will get 6 electrons and follow the octet rule. What is easy? To losing 2 electrons or to getting 6 electrons? Obviously to losing 2 electrons. So it will lose this electron. It will also lose this electron. Remaining will be beryllium plus 2. And in this case, 4 were the number of protons and 4 were the number of electrons initially. After losing 2 electrons, now the 2 electrons remaining, 2 protons are more than the electrons, so it is getting plus 2 charge on it. This is how we describe the charge on any element after forming cation or anion. I hope this particular thing is clear to you all, and you must know that how the cations are forming. Now, let's study how the anions are formed. Okay, so cations usually are shown by or formed by metals, and anions are formed by non-metals. In periodic table, this is how periodic table looks like. This, and this. This side is group 1 and group 2. These are metals, alkali metals and alkaline earth metals. Then here we have group 3, 4, 5, 6, 7, 8. 8 are the noble gases and remaining. Here in this side, this is group 8. This is group 7, group 6, group 5. So these 3 groups are forming anions. They have 5, 6 and 7 electrons in outermost shell. So it is convenient for them to get electrons, and for these 1, 2 and 3, it is feasible for them to lose electrons to get stability. Now in anions, this side have non-metals, and non-metals have tendency to accept electron. For example, in group 7, the number of group is representing the number of electrons in outermost shell. In group 7, this is a nucleus, 2 electrons, and then 7 electrons, 1, 2, 3, 4, 5, 6 and 7 electrons. So is it easy for this element to get 1 electron or to lose 7 electrons? Obviously to get 1 electron. So this is fluorine. It has atomic number 9. It has 9 protons and it has 9 electrons, right? So it will get 1 electron. So let's say it is from lithium. So lithium donated this 1 electron and fluorine got this 1 electron, right? If you remember the previous slide, if you lithium had 3 electrons and it donated 1 electron and got duplet rule, following duplet rule, and got stability. So that lithium's electron is accepted by fluorine. Now 1 electron is added up. 1 electron is more than the number of protons, so it will have -1 charge. So lithium had +1 charge, fluorine has -1 charge. So both of them combine and form lithium fluoride, and this is the ionic compound. This is how ions combine together and form an ionic compound, and the bond between these two elements after forming of the ions is known as ionic bond. Is it clear? I hope this concept is clear to all of you, that how ionic bonds are formed, how ions formed, how they get stability, what is a chemical bond, and what is the role of this whole process. Basically, the main agenda of this whole process is to get stable. So when they are getting ions, they still are not stable. So for getting more stability, the ions combine together and they form compound. I hope this concept is clear to you all. Now I am going to give you a few examples of cations and anions which are forming ionic compounds, and let's discuss a few properties of ionic compounds. I am covering two topics simultaneously. One is ionic bond and then ionic compounds. First, I told you how ionic bonds are formed. When we have a cation and we have an anion, when they combine together, the bond between these two ions is known as ionic bond. And the compound which is formed as a result of this combination is known as ionic compound. So, properties of ionic compounds are here. I hope red is clear to you all, this color. If there is some problem in visibility, of any type of visibility, you can comment me or you can message me on Instagram to correct me or to tell me how to rectify the particular thing. So when I talk about ionic compound, this compound is formed by ionic bond, positive and negative. So whenever we have positive and negative, it has electrostatic force. Let's write it with the black, because that will be more visible. Okay, we have electrostatic force in it, right? Electrostatic force means when positive and negative combine, there is some force, and that force is known as electrostatic force. Then, if I talk about the strength of ionic compound, this bond is the strongest because it has electrostatic forces. If the bond is strong, that means it will have high melting point, high boiling point, right? Then we have conduction of electricity. We know that electricity is conducted due to electrons or due to some ions, some charges. So here we have electrostatic force. This is the compound, for example, NaCl. Na is positive, Cl is negative. So if the compound is in solid state, it is poor conductor of heat and electricity. But if the compound is in liquid state or molten state, aqueous state or molten state. Now what aqueous state and what molten state? Aqueous means dissolved in water. So when NaCl dissolved in water, it forms Na positive and Cl negative. And second situation is molten. When we are melting NaCl, it will be also Na positive and Cl negative. So if the ionic compound is molten state or in aqueous state, it is a very good conductor, of heat and electricity. But in which case? Only when it is aqueous or it is molten, right? If I talk about the state of ionic compound itself, so itself ionic compound is a solid. Clear? So that's all for today's lecture. I described you about chemical bond. The chemical bond is the attractive force between the elements. Then I told you about different types of chemical bonds. We had ionic bond, covalent bond, coordinate covalent bond, and dative bond. After that, I discussed about ionic bond. Ionic bond is formed when cation and anion combine together. So the combination has some attractive force, and that attractive force is called bond. After that, I told you how cations are formed, how anions are formed, what is the stability, what is octet rule, what is duplet rule. So with this, I told you about the properties of ionic compounds. I covered two topics simultaneously. One was ionic bond and second one was ionic compound and the properties of ionic compounds. I hope this topic is clear to you all. This topic is very basic yet very important because this is covering the whole basic chemistry. If you have idea about bonds, and if you have idea about the energies, idea about the strength of the bonds, then you can identify so many other things with this. With this, I hope you all find this video helpful. If you have any query, and if you want any, if there's any confusion, you can message me on my Instagram and you can comment down on the video. So I am attaching my Instagram link here. So with this, I hope you all find this video helpful. See you all in the next video, in which we are going to discuss all other chemical bonds. Thank you so much.